Part 3, marker color 3, rolling on right through. All right, so verifying solutions to differential equations. We kind of have already done this in the first part when we did like the introduction thing, but again, I just wanted to lay it out very clearly in this, section 3. So, you might have picked this up back in part 1 of the notes, but in order to verify if a given function is indeed the solution to a differential equation, all we have to do is some simple plug and chug. Things you never thought I would say. Plug and chug. Seriously, I never thought I would say it either. But, yeah. So, for instance, given the differential equation, dy over dx is equal to 4y over x. Okay, we know that this dy over dx, flashing back to part 1, is another way to write the derivative. So another way we could write this, if it makes more sense to you, is y prime is equal to 4y over x, right? Same thing, just different notation for the derivative. Okay, and now we are asked, is y equals 4x a solution? Y equals 4x. So again, all we have to do is plug that into our differential equation to see if everything works out. But again, y, we can't just plug in, right? Because, well, I mean, we have a y there. Right there, we need to find the derivative. Oh, yeah, the derivative. So the derivative of 4x is 4. So now if we're going to plug that in, we're going to have 4 is equal to 4y over x. Except for we still have that y in there. We don't want that y in there. But we know that y is 4x. So we have 4 is equal to 4 times 4x over x. So then we have 4 is equal to 16x over x. Those x's cancel on out. We have 4 equals 16. Well, last time I checked, 4 does not equal 16. So, not a solution to our differential equation. Circle the no, not a solution. All right, what about y equals x to the 4th? So again, we just want to plug and chug. But in order to do that, we need the derivative. So y prime is equal to 4x cubed. So now we have 4x cubed is equal to 4y over x. Again, we don't want that y in there, but we know that y is equal to x to the 4th. So then we have x to the 4th divided by x. Cancel, this becomes a 3. So then we have 4x cubed is equal to, would you look at that? 4x cubed equals 4x cubed. Check. Smiley face. That is, in fact, a solution to the given differential equation. Yay. All right, let's do some more. So again, as long as we are remembering the land of derivatives, this has all been pretty straightforward stuff so far. So hopefully you are kind of cruising through it, feeling good. All right, number 2, differential equation is f prime of x. So again, this is kind of why we went over all that notation in the beginning. We were using f primes and dy over dx and y primes. Okay, so f prime of x is equal to f of x minus x. Okay, so number 1 is f of x equals 2x, a solution. So again, in order to plug and chug, we need the derivative. F prime of x is equal to 2. So then we're going to have 2 is equal to f of x, which is 2x, minus x. So we're going to have 2 is equal to 2x minus x is x. 2 does not equal x. So is f of x equals 2x a solution? No, it is not. Frowny face. All right, what about our next one? They're saying, or we are asked, is f of x equal x plus 1 a solution? So again, in order to plug and chug, we need our derivative. F prime of x is equal to 1, right? Derivative of x is 1, derivative of 1 is 0. So then we're going to have 1 equals x plus 1 minus x. X minus x is 0. 1 equals 1. Check. Smiley face. So that f of x equals x plus 1 is, in fact, a solution to our differential equation. All right, what about f of x equals e to the x plus x plus 1. So again, in order to plug and chug, we need the derivative. So f prime of x the x is e to the x, the derivative of x is 1, the derivative of 1 is 0. So then we're going to have e to the x plus 1 is equal to f of x, which is e to the x plus 1 minus x plus x minus x. We get e to the x plus 1 equals e to the x plus 1. Check. Smiley face. That all worked out for us. So this also kind of gets us to start thinking about, wow, look, this was a solution and this was a solution, and those don't necessarily look like very similar functions. So, differential equations seem like they could be, pretty exciting. But yeah, so then I have 4 more practice problems down there. The answers are there. So I encourage you to work through those on your own. Open note quiz is coming, so you should definitely work through them on your own. But yeah, so answers are down there too, so you can check your ones.